Our big global winds, our westerlies, our easterlies, and our trade winds, and how they generated out of those big cells, our Hadley cells, our Ferrel cells, and our polar cells. All right, and those are all the function of the Coriolis effect, splitting into those cells. So really those big global winds are the product of the circulation of our planet. These regional and local winds function the same way. They have rotation to them. They are the product of differential high and low pressure cells, or warming and cooling parts of our planet. And I'm going to introduce them with 3 slides, and then each one of these winds is going to get their own little talk with their own little slide set. So the next series are going to be pretty small. So the winds that we're going to cover are monsoon winds, land and sea breezes, mountain valley breezes, Kadiabatic winds, or Fajol winds, or Chinook winds as they're known here in North America. So just a reminder that the land-water heating relationships are really important in generating winds, and more so with regional and local winds, because those big global winds are being driven by the energy that's coming out of the intertropical convergence zone and then being distributed across the planet. These winds are affected by those conditions, particularly the pushing of these high and low pressure cells across and back and forth across the equator. But more so, we've got smaller, more gentle winds because of this differential heating that it results. So as a reminder, land heats and cools really quickly because it doesn't have the capacity to store energy. It doesn't have the same volume of hydrogen bonds that water has. Every other bond mechanism between those atomic particles is much weaker and can't hold energy. So that means that in the wintertime, land can't hold energy, so it's going to be cold. If it's cold, it's going to have a high pressure cell because it's not emitting heat. In the wintertime, water, on the other hand, has stored all its heat over the summertime. It's at capacity near the end of the summer through to the beginning of fall. As fall is progressing, it's starting to give that heat up, and as winter's progressing, it's giving that heat up, that heat energy out, and it's emitting that heat. So it's much warmer. It's much warmer than it is over the water than it is at the land at the same time. Because it's much warmer and it's lifting, what's happening is the air is going to be buoyant and there's a low pressure cell. Summer, on the other hand, is going to have the reverse effect. What's going to happen is on land, that energy is released right away, and because it's released right away, it's going to be a low pressure cell. The energy is really active. Water, on the other hand, is like, hey, I'm empty. Let's fill those hydrogen bonds again. So the sun that's striking the surface of a water body all those hydrogen bonds are going to take that energy and store it up. So it's not giving it off, so it's not going to give up some energy. So we're going to have a high pressure cell over the water. Consequently, we can look at local or regional high and low pressure cells this way, and we get these sort of generated cells that are more continental or local as an effect. So if we take a look at what's happening right above the Great Lakes, we see that where we know that water has that capacity to store and release energy slowly. If we have a high pressure cell sitting over water, it must mean that the water is cool. If the water is cool, it's taking in energy, it's not giving it off, which means it's got to be a summer scenario in this diagram. So we've got a summer condition where we're taking in energy, creating a high pressure cell over these water bodies, as opposed to out here Over Wyoming, we've got a big low pressure cell generated. We don't have a lot of water bodies sitting out here in the western part of the United States. We've got the Great Salt Lake here, but the Great Salt Lake is relatively small compared to these big boys over here, and it's rather shallow. So it's not going to generate a lot of pressure here because it's not relatively significant compared to the large landmass around it. So we're going to generate a low pressure cell here because the landmass doesn't have the capacity to store energy. It's giving that energy off. In the wintertime, you're going to see this scenario reversed. This is going to be cold because we don't have any energy to give off. So it'll be a high pressure cell. This is going to be warm because we're finally giving off that energy and releasing it back into the atmosphere. And so we're going to have a low pressure cell there consequently. All right, keep those concepts in mind as we generate monsoons, land sea breezes, kadiabatic winds, mountain sea breezes, and then Fajol winds.